Hey everyone, welcome back to the channel. Today we are going to talk about an essential database scaling technique called sharding. If you are aiming to scale your database to handle millions of users or massive amounts of data, sharding might be the key solution you need. In this video, we will cover what sharding is, why it's useful, and how to implement it effectively. So let's dive right in. The first, what is sharding? Sharding is a database architecture pattern that involves splitting a single large database into smaller, faster, and more easily managed parts called shards. Each shard is a separate database that holds a portion of the entire database set. Think of sharding like diving a large warehouse into smaller storage units. And instead of having all your inventory in one giant space, you split it into smaller organized sections. Each section or shard can be managed independently, making the overall system more efficient. So let's talk about why to use sharding or why sharding is important. The first thing is the overcoming database limits. One of the main reasons to use sharding is to overcome the limitation of a single database. As your application grows, a single database can become a bottleneck in terms of performance, storage, and query processing time. Imagine you have an application that stores millions of users' profiles. A single database will struggle to manage all that data effectively, leading to slow queries and downtime. By sharding the database, you distribute load across multiple shards, which significantly improves performance. Number two, improved read and write performance. Sharding helps distribute read and write operations across multiple servers, which improves overall system's performance. Since each shard is only responsible for a subset of the data, operations are processed faster. For example, in a social media app, you might shard users by their geographic location, so users in different regions are stored in separate shards. This way, user requests are spread across different shards, reducing the load on a single shard. Three. No, 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 no. Yeah. Okay, this is better. Where we are. Yeah. Three will be the scalability and fault isolation. Sharding allows for horizontal scaling, meaning you can add more shards as your user base grows. Additionally, if one shard fails, the other shards remain unaffected, providing some level of fault isolation. If one shard goes down, only a portion of users are affected. The rest of the system continues operating normally, which is crucial for maintaining uptime. Okay, let's talk about how does sharding works. First, we have a short key. This is how shard works in general, but this is we have a short key. So the key to effective sharding is choosing a good sharded key. The shard key determines how the data is split across shards. Ideally, it should evenly distribute the data and the load. For instance, if you are sharding a database of user profile, you could use the user ID as a short key to eventually distribute user across shards. The goal is to avoid having one shard overloaded while others are underutilized. Let's talk about the types of sharding. The first thing we will have the range sharding. Range sharding divides data into ranges based on the shard key. This straightforward but can lead to hotspots if one large gets more traffic. The second there is a hash sharding. Hash sharding applies a hash function to the shard key to determine which shard can or which shard the data belongs to. This method distributes data more evenly. There is a geo sharding. Geosharding charts data based on geographic location, which can be useful for applications with users in different regions. For example, range sharding might be used if you are sharding data by date, while hash sharding is often used when you need to evenly distribute data without predictable patterns. Okay, let's talk about some challenges we face in sharding. The first thing in complexity in maintenance. Sharding introduces additional complexity, especially when it comes to maintenance. Managing multiple databases can be challenging, especially when you need to replace shards or move data between them. For instance, if one shard grows too large, you may need to reshard the data, which can be complex process that involves um, redistributing data to new shards without causing downtime. Another thing which will be the cross shard query. Another challenge is, as I said, the cross shard query. When data needed for query spans multiple shards, it can lead to increased latency and complexity in data aggregation. Imagine trying to generate report that needs to pull data from multiple shards. This can lead to slower response times um, and the need for additional logic to combine data from different resources. Let's talk about best practices in shards. And the first thing we will talk about, which is to plan your key carefully. The choice of a shard key is crucial for ensuring an even distribution of data and avoiding hotspots. Consider your access pattern and choose a key that distributes the data evenly across shards. The second is monitor and adjust. Use monitoring tools to keep an eye on shared sizes and performance. This helps you identify any imbalances and take actions before they become major issues. 3. Automate rebalancing. If possible, use tools or performance that provide automated rebalancing. For instance, cloud providers like AWS and Azure offer managed databases that support sharding and can help with rebalancing when shards become unbalanced. So, to sum it up, sharding is a powerful technique for scaling your database horizontally and improving performance as your application grows. When it becomes with added complexity, effective planning, and the right tools can make sharding an essential part of your scaling strategy. If you found this video helpful, make sure to like it, subscribe, and hit the notification bell so you don't miss out on any more content about database scaling and system design. As always, if you have any questions or experiences with sharding, drop them in the comment section below. I would love to hear it from you, and thank you for watching, and see you next one.